We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system. Take a look. The striking infrared images were taken this summer by the James Webb Space Telescope. They show Neptune's thin rings, faint dust bands, and 14 moons. It's the sharpest view we've had of Neptune since Voyager 2 zoomed past the giant ice planet in 1989.
The James Webb Space Telescope was scanning the far reaches of our solar system with its razor-sharp infrared eyes when it stumbled on something that shook astronomers to their core. Buried in the stream of data was Neptune, the distant ice giant nearly 30 times farther from the Sun than Earth, flashing a signal so wild it could only mean one thing. A massive collision had just rocked the planet. Shockwaves ripped through Neptune's atmosphere, and Webb's instruments caught the thermal scars and chemical traces written across the skies in real time, an unfiltered glimpse at a cosmic smash-up of epic proportions. Neptune has always been wrapped in mystery. Despite being the fourth largest planet, its dim, faraway glow has kept it out of reach for most of history. Voyager 2 gave us our first close encounter back in 1989, revealing fierce winds, raging storms, and that deep sapphire hue carved by methane gas. Since then, astronomers have had to rely on Earth's telescopes, and now Webb's, to watch its shifting clouds, faint rings, and strange moons. But never, not once, have we seen a direct impact unfold on Neptune with our own instruments. Until now. Webb didn't just spot a sudden surge of heat rising through the clouds, it also exposed alien fingerprints in the atmosphere, proof that something foreign had slammed into the planet and disintegrated under its crushing gravity. A rogue traveler turned into cosmic dust, staining Neptune's skies for the first time in human history. To grasp just how insane this really is, remember, Neptune is a beast. Nearly 4 times Earth's size and packing 17 times the mass, its gravity rules the outer solar system like a heavyweight champion. For an object to scar a world this big, it couldn't be just a puny asteroid. We're talking a monster body, possibly tens or even hundreds of kilometers wide. Webb's data hints it could have been a stray comet or an icy outlaw from the Kuiper Belt, finally dragged to its violent end against the frozen giant. The sheer violence of this crash is almost beyond imagination. Even though Neptune's thick atmosphere absorbed the blow, the energy released would have rivaled millions of nuclear blasts detonating all at once, a cosmic power surge no human mind can fully picture. But this wasn't the fiery Hollywood-style explosion we imagine when asteroids hit Earth or Mars. Neptune is different. Its atmosphere is a rolling ocean of hydrogen, helium, and methane, swirling like a storm without end. As the intruder tore into those icy clouds, it didn't smash into a hard surface. It crushed the atmosphere itself. Shockwaves ripped outward faster than sound, shaking Neptune's skies as the object broke apart and dissolved in the planet's hydrogen seas. Webb's instruments caught the fingerprints of that death. Sudden spikes in carbon-rich molecules, and strange spectral lines pointing to exotic ices, maybe ammonia or carbon dioxide, dumped into Neptune's skies by the foreign invader. That chemical scar could linger for decades, a haunting reminder of a single violent moment. What makes this even more shocking is the myth it destroys. For decades, Neptune seemed like the quiet loner of the solar system, drifting peacefully in the cold, far from the chaos of the asteroid belt or the storms of Jupiter. But Webb just proved that even out here, nearly 3 billion miles from the Sun, collisions still happen. This wasn't some ancient relic of the solar system's birth. This was now. A live reminder that the cosmos is still throwing punches, and the implications stretch far beyond Neptune itself. Catching an impact in real time gives astronomers a golden chance to refine their understanding of how these crashes shape planets everywhere, from our own backyard to worlds orbiting distant stars. Impacts aren't just history written in craters. They're an ongoing force that drives the evolution of entire planets. Impacts aren't just random crashes. They're cosmic game changers. They deliver volatile chemicals, stir up atmospheres, bend orbits, and sometimes even strip planets down to their bones. On Earth, they've flipped the script of life more than once, from the asteroid that wiped out the dinosaurs to earlier strikes that may have seeded our world with water and the building blocks of biology itself. But when it comes to gas and ice giants, the story is murkier. With no solid surface to scar, direct evidence is hard to find. That's why Webb's detection of Neptune's hit is priceless, a once-in-a-lifetime chance to watch what happens when a monster object dives into a gaseous world. And it's not just about Neptune. This may be the same kind of chaos unfolding across exoplanetary systems all over the galaxy. The sheer energy of the impact likely punched deep into Neptune's layers, rattling its atmosphere in ways scientists are only starting to unravel. Remember, this is already a planet where winds scream at over 1,500 miles per hour, the fastest in the solar system. Add the heat and momentum of an impact, and you've got a recipe for supercharged chaos. Winds twisting into wild vortices, storms mutating into fresh monsters. Webb's later images even revealed strange bright spots and distortions in Neptune's cloud bands, shifting patterns unlike anything seen in decades. These fleeting scars may be the atmospheric echo of the collision, turbulence frozen into motion by raw cosmic violence. But the biggest prize for planetary scientists isn't just the storms, it's the chemistry. Webb's instruments can break down light with microscopic precision, detecting molecules at levels as fine as a few parts per billion, and what they found was shocking: exotic compounds floating high in Neptune's skies, proof that the intruder carried alien material straight into the giant's atmosphere. This is like Neptune becoming a natural space lab, giving us samples from the farthest edges of the solar system without even sending a probe. If that object came from the Kuiper Belt, its chemistry could be a frozen time capsule, a remnant of the very dawn of the solar system itself. By slamming into Neptune, the mystery object did something wild. It made itself easier to study. Its shattered ingredients scattered across the skies, glowing in Webb's infrared view like a cosmic confession caught on camera. The sheer luck of witnessing this event makes it even more unbelievable. Astronomers think collisions on Neptune happen only once every few centuries, or even millennia. Yet Webb was watching at the exact right moment, proving its worth as the ultimate space watchdog. Unlike Earth-based telescopes struggling to see through our atmosphere's blur, Webb's perch in deep space gives it front-row seats to fleeting, once-in-a-lifetime events. It's not just built for staring at the oldest galaxies, it's also a sharp-eyed guardian of our own cosmic neighborhood, catching drama in real time. This moment isn't just a discovery, it's proof that Webb has tricks up its sleeve we haven't even imagined yet. But here's where it gets even more intriguing. Neptune isn't just a victim, it's a player in this game. Sitting right inside the Kuiper Belt, a frozen junkyard of icy leftovers from the dawn of the solar system, Neptune's gravity has spent billions of years shaping, trapping, and ejecting bodies like a cosmic bouncer. The very object that slammed into it may have been one of Neptune's own rejects, shoved onto a collision course by the planet's gravitational pull. Talk about irony. Neptune basically summoned its own attacker. This impact is a raw reminder that the solar system is a constant dance of push and pull, with planets and smaller bodies reshaping each other through invisible tugs, and sometimes through catastrophic blows. And for scientists studying exoplanets, the stakes are even higher. Most of the worlds we've found around other stars are gas and ice giants just like Neptune, orbiting far from their suns. Watching this real-time collision doesn't just tell us about our backyard, it's a live model for what might be happening light years away. Impacts like this could reshape alien atmospheres, spark massive storms, or even shift the odds of moons carrying life. The Webb telescope isn't just spying on Neptune, it's rewriting the playbook for how we study alien worlds. The same precision that exposed this planetary smash can now be turned toward distant exoplanets, decoding their atmospheres by comparing every spectral fingerprint against Neptune's collision scars. What Webb saw here could become the master key for unlocking the secrets of planets orbiting stars light years away. But the drama doesn't stop at discovery. It hits home too. This impact carries massive weight for planetary defense. Earth has a safety net thanks to Jupiter and Saturn, which act like giant shields pulling in or swatting away countless space rocks. Yet Neptune's violent encounter proves one thing loud and clear. The outer planets are still taking hits, and those hits are part of the ongoing survival game of our solar system. Watching Neptune soak up a colossal impact is both chilling and comforting. A reminder that these cosmic heavyweights sacrifice themselves, sparing the smaller inner worlds from many deadly encounters. Our planet's safety is partly written in the scars of the giants, and the mysteries are only deepening. Webb's data shows strange chemical lines that don't match anything we know, proof that exotic reactions may have sparked as the intruder's remains mixed with Neptune's bizarre chemistry. We may be looking at molecules so rare they barely exist anywhere else, new secrets for astrochemists to chase. Even the heat signature from the crash was shocking. It lingered longer than expected, hinting that the energy dug deep into Neptune's mysterious layers. Down there, under crushing pressure, scientists believe oceans of superheated water and exotic ices may exist. An interior stranger than science fiction. This impact might just be the first real clue to what hides beneath the planet's stormy shell. What Webb captured is not just one chaotic event. It's a chapter in the epic story of planetary evolution. A collision on Neptune, yes, but also a mirror showing us how worlds grow, change, and protect each other in the endless dance of cosmic survival. Neptune, once dismissed as a quiet, frozen loner, has now been exposed as a stage for cosmic drama. What Webb captured wasn't just another data point, it was a front-row seat to one of the universe's most primal forces, collisions. These crashes don't just destroy, they rebuild. They wipe out old structures while planting the seeds for something new, the same violent recipe that once shaped Earth itself and continues to sculpt the galaxy today. This discovery will echo for years to come, not just as Neptune's story, but as a glimpse into countless unseen impacts happening across the cosmos. For every collision we manage to catch, thousands more go down in silence, hidden in the dark. Yet thanks to Webb's piercing eyes, one of these cosmic secrets has been dragged into the light, letting us witness the raw mechanics of planetary evolution with stunning clarity. Neptune's collision isn't just an accident. It's an invitation to recognize the solar system as alive, restless, and forever rewriting its own script in fire and ice. But here's where it gets even juicier. The crash didn't happen in a vacuum. It slammed into a delicate environment filled with moons and faint rings, each one tethered to Neptune's pull. A collision of this magnitude doesn't just scar the planet. It shakes the whole system around it, raising new questions about how such events ripple outward through gravitational chains. Watching a gas giant get struck in real time forces astronomers to confront deeper mysteries about how planets, moons, and rings interact in ways we've barely begun to understand. Neptune has always been overshadowed by its flashier neighbors, Jupiter with its colorful belts, Saturn with its iconic rings, but don't be fooled. Neptune hides its own arsenal of mysteries. Its faint arcs of rings and stormy, shifting skies reveal just enough to tease, while concealing more than they explain. And now, into this enigmatic world, a massive intruder has fallen, leaving scars not just on Neptune, but on the story of the solar system itself. Neptune's 14 moons, led by the mysterious Triton, may have felt the aftershocks of this impact, their orbits shifting ever so slightly over time. Even tiny changes in Neptune's gravity could ripple across centuries, rewriting the choreography of its moons. Triton itself, bigger than Pluto and captured from the Kuiper Belt long ago, mirrors this story. An outsider pulled in, just like the new intruder that smashed Neptune. Its icy surface with nitrogen geysers could even hold traces of fresh disturbance. And Neptune's faint, fragile rings? They might already be glowing with new dust from the crash, silent evidence of cosmic chaos still unfolding around the planet. Could Neptune's crash be proof that ring systems across the solar system were born from violence? Saturn's dazzling rings may not be unique. Neptune's faint arcs could have been fed by chaos too. This fresh collision is a live case study, showing how wandering bodies can smash into giants and spark whole new structures. From a bigger perspective, the event screams one truth. The outer solar system is no frozen wasteland. It's alive with motion. Resonances, gravitational shoves, and long-term migrations constantly stir the pot. The Kuiper belt itself, along with strange trans-Neptunian objects, are evidence of past upheavals. So a body slamming into Neptune isn't just luck. It's the final step in a chain of nudges stretching across billions of miles. Scientists now see this as part of a hidden choreography, one where Neptune, passing stars, and even the far-off Oort cloud play a role in steering cosmic intruders inward. But the real intrigue lies below Neptune's stormy shell. Inside the planet lurks a mantle of exotic matter, water that's both liquid and crystal, ices that conduct electricity, and layers twisting its tilted magnetic field. The impact Webb caught may have rattled these secret depths, stirring strange currents or triggering rare reactions we've never witnessed. We can't peer directly into Neptune's heart, but the clues may appear in its magnetic field, glowing auroras, or long-lasting thermal glow. And remember, Neptune already radiates more heat than it gets from the sun, proof that something powerful is brewing inside. This collision may have poked that mystery wide open. This impact wasn't just a spectacle, it was a natural experiment in planetary physics. Webb may have caught Neptune's heat flows and magnetic field twisting in real time, giving scientists a rare chance to track changes as they unfold. And the lessons don't stop there. They stretch far beyond our solar system. Thousands of exoplanets have already been cataloged, many of them Neptune-like giants circling alien stars. But what if some of their strange atmospheric signals are actually scars of past collisions? Without a reference, those mysteries would stay unsolved forever. Now, with Webb's detection, astronomers can build a catalog of impact fingerprints, chemical spikes, heat bursts, cloud anomalies, a cosmic cheat sheet for decoding distant worlds. And the ripple effects may not be over. Neptune swims in a sea of icy bodies, its gravity holding some close while kicking others out. If one impactor made it through, who's to say more won't follow? Over cosmic timescales, Neptune may be struck again and again, each collision nudging its evolution, fueling its savage winds, and feeding its strange heat balance. The giant could be quietly reshaping itself, one blow at a time. But here's the bigger truth. Collisions are the universe's way of reminding us that nothing is permanent. Worlds can drift in silence for eons, only to be shattered in an instant. For us here on Earth, these distant cosmic battles are a mirror, showing that the same forces that once remade our planet are still alive, still writing the story of the solar system. Neptune's collision, captured in stunning detail by Webb, is more than a curiosity. It's proof that creation and destruction never stop in the cosmos. The aftermath could reshape Neptune for decades, stirring new storms, warping its rings, even shifting its moon's orbits. Each ripple is a priceless data point in a natural experiment no lab could ever recreate. Webb has opened the door, but this is just the beginning. A future probe orbiting Neptune could reveal consequences we can't yet imagine. And the message is clear. Collisions like this aren't rare accidents. They're part of the solar system's design, reminders that the same forces battering Neptune could one day threaten Earth. Neptune's sacrifice isn't just academic, it's a warning and a lesson. By showing how gravity herds wandering bodies into collisions, this impact gives us critical insight for protecting Earth from the same fate. But the meaning runs deeper. For centuries, humanity has tied myth to the heavens. Neptune, god of the sea, comets feared as omens, and now Webb has caught a real cosmic strike on a planet named for a deity. The gods may be silent, but the universe still throws spectacles of staggering power. This discovery transcends science. It sparks imagination, fuels art, and reminds us that exploration is about wonder as much as knowledge. Thanks to Webb, Neptune has transformed from a distant mystery into a stage where cosmic forces reveal themselves, and where humanity is no longer a spectator, but a witness. While Triton steals the spotlight, Neptune also holds a family of fragile little moons, tiny, irregular satellites likely captured from the Kuiper belt. A massive impact could have rattled their delicate orbits, showered them with debris, or even coated their icy shells with exotic material from the intruder. These moons might now be carrying chemical fingerprints of the crash, acting as natural archives of the event. This isn't just about Neptune today. It's a modern echo of the solar system's violent youth. Earth's moon was born of a colossal impact. Uranus was tipped on its side by one, too. What Webb saw on Neptune may be a smaller version of those ancient cataclysms, playing out in real time. And the implications reach even further. Collisions may be the couriers of life's ingredients, delivering water and organics across planets, just as they may have once done for Earth itself. Neptune's collision may have delivered more than destruction. It could have enriched the planet's chemistry with frozen hydrocarbons, ammonia, or nitrogen compounds. While Neptune itself won't host life, the principle is universal. Impacts act as couriers of chemistry, scattering building blocks that might spark habitability elsewhere. But the real spectacle may be in the skies. Neptune already holds the fastest winds in the solar system, and a sudden surge of impact energy could have unleashed atmospheric chaos, pressure waves like space tsunamis rolling across the planet. If Webb caught shifting brightness or rippling cloud patterns, it may be the first proof of this kind of violent dynamic. For scientists, this is gold, a natural experiment showing how atmospheres respond to shocks, refining not only Neptune's climate models, but those of distant exoplanets too. By comparing Webb's Neptune data with alien worlds, astronomers can finally tell apart steady chemistry from scars of cosmic collisions. A planet showing strange levels of carbon dioxide or methane might not be a mystery at all. It could simply be the scar of a massive impact. In this way, Neptune becomes a cosmic reference point, helping us decode the atmospheres of worlds light years away. The drama may even reach into Neptune's bizarre magnetic field, tilted, offset, and unpredictable. A hit this powerful could have jolted its currents, sparking fresh auroras across the poles and offering a rare look at how planetary shields react to sudden shocks. That knowledge is crucial for understanding space weather, including the system that protects Earth itself. And bigger still, Neptune proves the outer solar system isn't frozen or finished, it's alive and evolving. Each collision reshapes orbits, sculpts the Kuiper belt, and rewrites the long-term stability of the solar system. If you want to keep uncovering these cosmic revelations, smash that like button, drop a comment, share this video, and make sure you subscribe. The next discovery could change everything.